What's up, everybody? Welcome to Cam School. Today we'll be talking about Snell's law. So Snell's law basically explains and quantifies what happens when light goes from one medium to another medium. So for example, when light goes from air to water, or light goes from water into another substance, say a diamond. So let's consider light for a second. Well, we understand that light is an electromagnetic wave as shown here. However, when we consider Snell's law and look to quantify what happens to the light, we consider light as a straight ray as shown here. It makes things a little bit easier. So, when light goes from one medium, in this example, from air to another medium, water, it slows down. It's a lot like when you have a car going along a road, an asphalt road, cruising along, and it hits a patch of mud. When the first wheel on the tire hits the patch of mud, it slows down. And because that tire slows down, the car will slightly turn off course, right? Light does the exact same thing. So here we see the light traveling along in air. But once it hits that mud patch, the water in this case, water slows that light down. So it kind of turns its course a little bit off course. So we see here this blue angle. Is bigger, the angle of incidence, and the angle of refraction is a little bit smaller, right? So blue bigger than green. And that's because the water slows it down. So the light in air is C. That's 3.0 times 10 to the 8th meters per second. The new velocity in the other medium that it's entering is V. When you divide C by V, you get N, and we call that the index of refraction. The index of refraction basically tells us the magnitude by which light in a vacuum slows down by entering the new medium. And we can calculate that here. We can calculate N or we can calculate V by what we're given. So, when light travels from one medium to another, you get two pieces of information. The first piece of information is what's the indexes of refraction. You also find out the second piece of information, which is what's the angle of incidence and what's the angle of refraction. So, in a problem, you can be given three of these things and be asked to solve one of these things. And so we're going to practice that here. So here's the basic steps for solving. You always want to have a perpendicular line to the border between the two mediums. So that's step one. Step two is you want to write your knowns in your info. So we'll look down towards the bottom. And here we have N1, we have theta 1, the angle of incidence, we have N2, and we don't know the angle of refraction. So that's what we're going to solve. We're going to solve for the refractive angle. And we know all of these things here. So we know Snell's law, N1 sine theta 1 is equal to N2 sine theta 2. And so we can kind of manipulate our equation here to solve for this theta 2. So we can move N2 on this side, and then we can take the sine inverse of that to solve for this theta 2. And basically you plug and chug your numbers in here, plug and chug, and then you'll get your answer. And for simplicity, I won't plug in the numbers and kind of confuse you. As long as you understand that you're usually given three pieces of information and you're solving for the final piece using Snell's law. So couple of tips when you're working with Snell's law and doing problems with Snell's law. First of all, you want to ask yourself, is the ray being squished? So number one here, is the ray being squished? When the ray of light is traveling from a medium to another medium and it slows down, this ray here will be squished down towards your perpendicular line. That's only when the ray of light goes from a medium into another medium and it slows down. Okay, so in this problem, it's going from air to water and it's slowing down. It's slowing down. And so it's looking like, it kind of appears like this angle, this green angle, is being squished, right? The green is smaller than the blue. Okay? Also, when you get an answer, you want to ask yourself, do the answers make sense according to Snell's law? So let's write out Snell's law. Sine theta 1, sine theta 2. Okay? And for this problem, we know that this is 1, and we know that this is 1.33. And we know that both parts of these equations are equal to each other. So, if you found your answer for theta 2, for example, we have to understand, and we can check, because this side has a smaller n, and this side has a bigger n, that means for both sides to be equal, this sine theta 2 has to be smaller, and sine theta 1 has to be bigger, right? So it's small n with big sine theta 1 will equal big N with small sine theta 2. And that's one way you can confirm and make sure that your answers are correct. And so that's Snell's law in a quick video. Always remember, Snell's law helps you understand and quantify what's happening when light goes from one medium to another medium.